All right, today we are going to talk about tangents to circles. This is different than the other tangent that you guys used with your right triangles. Okay, tangent to a circle is going to be a segment or a line or a ray, it could be any of those, that intersects the circle in just one point. Okay, so it just kind of grazes it and then continues on from there. Okay, so this would be an example of a tangent here. Okay, it could end up having this be line AB. Again, it could be a segment or a ray as well that would work as a tangent. Okay, the point of tangency is where it intersects, so A would be considered the point of tangency here. Okay, and then we also have what's called a common tangent, and that's just going to be a line that's tangent to two or more circles. So if I had another circle over here with the B, this would be considered a common tangent because it's tangent to two circles when you're working with it. Okay, but again, big idea is tangent intersects only once. Okay, and then we're going to do some unique things with that here as we go throughout this lesson. So example 1 just asks you to draw the common tangent. Okay, I'm going to jump over that one. You can check that one on the completed notes to make sure you get drawn correctly. Again, just to save us a little time here. Okay, but it's wherever they intersect each other. Okay, I'm going to go on to the next theorem because this one is going to be the big one for us. Okay, so I'm just going to erase one of our circles here, so we do just have one of them that we're working with. Okay, so this would be theorem 1010, and it says a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. Okay, so if you've got your center here and you draw a radius from the center to the point of tangency, that will always make a right angle, which will allow us to work with some of our right triangle stuff again. Okay, so again, radius to tangent, always a right angle. That's going to be very, very important for us as we move forward here. Okay, so example 2 then is going to have us go ahead and look at this. Okay, so if we look at example 2, the first one that we have, our A, they give you a circle with its center at A. It gives you a point of tangency C, and that's drawn in, and then it continues out to make a triangle. Okay, they tell us that this whole distance is going to be 17, and they tell us we have x and 14. Okay, so we again know a radius to tangent makes a right angle every single time. Okay, now if you look at your right triangle, you have two sides looking for a third side, which means we do want to use the Pythagorean theorem. Okay, again, 17 will be the hypotenuse, so I'll have an x squared plus 14 squared equals 17 squared for this one. Okay, you can go ahead and if you subtract them, you end up getting 93. 93 does not have any perfect squares that go into it, so we will just leave our answer as the square root of 93. Okay. So for the next one then, same type of idea here. We got B this time. This one will be a little bit different. It has one added thing to it though. Okay, so for this one you have a Q. R is at the center, and then you have S somewhere out here. Again, where Q is at will make a right angle for us. Okay, again, dealing with the tangent and the radius. You're going to end up, you have 4 over here, you have 2, and you have X. Now, what you'll notice is you actually don't have the other piece here. You don't have QR, but you do. Okay, you just have to look for it. You have to look for another radius because QR is a radius. Another radius I have is this piece right here. So if this one is X, that means that this one has to be the X because all radii have the same length. Okay, so we are still going to do Pythagorean theorem. I know you have two X values. That's okay. It doesn't make a difference. We can still work with it. Okay, so making sure we know that this side will be my hypotenuse. So it will end up being x squared plus 4 squared equals x plus 2 squared. Okay, very important we realize we actually have to FOIL this out. Okay, making sure that you distribute or FOIL everything. Again, I prefer distribute over FOIL. Okay, so you end up with an x squared plus 16 equals x squared. 2x and 2x will give you 4x plus 4. You will notice the x squareds do cancel each other out, so we won't have to factor. Okay, so then I can subtract my 4, and we'll get 12 equals 4x, so we will get x equals 3. Okay, so again, a little bit of that distributing. We haven't done that in a little while, but you may have to do a little bit of that here. Okay, so that's kind of solving. Anytime they're asking you to solve, working with a tangent and a radius, want to work with that Pythagorean theorem, working on finding the missing side. Okay, example 3 asks you to determine whether GH is tangent to circle F, and then asks you to justify your answer. So we're basically testing to see if it works or not. Okay, so if you look at this one, okay, they give you the circle, and then they give you a triangle that kind of looks like this. Okay, oops. Yep, drew that the wrong way here. Try it. And it looks more like that. Okay, it tells you that this side is 12, it tells you this side is 8, and this side is 6. And they're asking you, is it a tangent? Well, if it's a tangent, then it works in the Pythagorean theorem. If it doesn't work in the Pythagorean theorem, then it's not a tangent. So we do want to test it. Okay, we know the longest side would have to be the hypotenuse if this is going to work. So I'll have 6 squared plus 8 squared, and I want to see how does that relate to my 12 squared. Well, 6 squared plus 8 squared is 100, and 12 squared is 144. Those do not equal each other. If they do not equal each other, then it is not a tangent. Okay, so I would say no, and then this would be my justification. Okay, those numbers are how you justify it. If they're equal, perfect, then they'd be equal. If they're not, then it is not a tangent. Okay, but that's how we would want you to justify that. Okay, and we kind of got two more things here we want to talk about real quick. So your next theorem says if two segments from the same exterior point are tangent to a circle, then they have to be congruent. Okay, so what we're talking about here is if I had a tangent out here and I drew it to each of my circles. Okay, so from this tangent to an exterior point, tangent to an exterior point, these two will always be congruent to each other whenever we are working with them. Okay, so example 4 has you work with that. It asks you to find the value of x. Assume that segments that appear to be tangent are tangent. So for this one, I know I kind of have mine flipped around here, but I'm just going to go ahead and use this picture. Okay, they've got Q, R, and S. Okay, so they give you that QR is 3x plus 8, and they tell you that SR is 26. Okay, so since they're both tangent, okay, at Q and S to that point R, that does mean that they will be equal to each other. So we would set 3x plus 8 equal to 26. Go ahead and solve that like you normally would, and you'll end up with x equals 6. Okay, so again, just always congruent, which means we can set them equal to each other. And then we're going to use that same idea for the last thing here. You'll notice we have a circumscribed polygon. I talked about how we would be getting into these a little bit more. Okay, for the most part, we've had the circle on the outside and the other shape on the inside. Okay, I'm going to go ahead and flip-flop that today. So a polygon is circumscribed about a circle if every side is tangent to the circle. Okay, so basically like we talked about before, okay, each side has to touch the circle. Okay, so it'd be kind of like this, where it touches here, touches here, touches here. Since it's a triangle, there should be 3 points where it touches, one on each of the 3 sides. That would be considered a circumscribed polygon. Okay, so then example 5 kind of has you use that with the quadrilateral. Okay, so you're given what appears to look like a trapezoid. Okay, you have the circle, Okay, and then it kind of goes like this. I'll do my best to draw this one here. And kind of goes like that. Obviously the one you guys have looks a whole lot better than mine. Okay, it does go ahead and tell you that this piece is 3. Tells you that this piece is 3. Tells you this piece is x. And it tells you this piece is x. And it asks you to find x, and it tells you the perimeter is 18. Okay, so what we have to do first is find all these missing pieces, but notice all you have are a bunch of tangents. Okay, so this would be an exterior point, okay, tangent, tangent to the circle. So if this one's x, then this one also has to be x. And we're basically going to do that same thing all the way around. If this is 3, this is 3. If this is 3, this is 3. If this is x, this is x. Okay, so it kind of works all the way around, and it tells us perimeter is 18, so I want to add all those up to equal 18. So x, 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 x would be a 4x. 3, 3, 3, 3 would be 12, and that would have to equal 18. Do your normal solving, and you would end up with x equals 1.5, or 3 over 2 if you wanted to leave it that way. All right, and that covers our lesson on tangents. Again, make sure you check the assignment in the daily agenda. Don't do the one in your notebook because we did adjust them a little bit to try and help you guys out with this stuff. Have a great day.